Hello everyone and welcome back. In this lesson, we are going to be looking at solving exponential equations. So we are going to revise the basic rules of indices and use those facts to solve simple exponential equations. Let's begin by looking at the index properties or rules. The first one here is the product rule or the product property. And what it says basically is that if we're multiplying similar bases, then all that we need to do to complete our question or to simplify is just to add the powers. So a to the m times a to the n is equal to a to the m plus n because the bases are similar. We add the powers. The power rule says that if we are taking a power to another power, that is a to the m times raised to the n, a to the m raised to the n, then all that we do is multiply m by n. The quotient here with a power. So if you have a quotient raised to a power, then both numerator and denominator are raised to that power. Of course, you shouldn't have a 0 in your denominator. That would make the whole thing meaningless. And the power of a product, of course, if we're raising a product to a power, then both parts of the product, doesn't matter how many parts there are, all of everything inside the bracket that is raised to the power gets raised to the power outside. So a to the m, b to the m. And the quotient rule here, which is sometimes called the division rule. The division rule says that if we are dividing similar bases, then what we need to do is to subtract the powers. So a to the m divided by a to the n would give us a to the m minus n. Also, something that comes up often here, which we need to remind ourselves of, is negative indices. So we can remind ourselves here that a to the minus m can be simply written as 1 over a to the m. Those are very important and tend to pop up a lot when you're doing indices exponential equations. So let's look at our first question. Here we have 2 to the n is equal to 8. We have another one, 3 to the n is equal to 1 over 3. So 2 to the n equal 8. And what we're going to be doing here is to make sure that both sides of this equation are in the same base. So we have 2 to the n equal 8. But this needs to be written as a power of 8. Now you remember that 8 is equal to 2 times 2 times 2. So 8 is equal to 2 to the third. So we can write this as 2 to the n is equal to 2 to the third. And because our bases are equal now, we can simply equate our powers. So we can say n therefore is equal to 3. And that is the solution we need for our question. In solving this similar one, 3 to the n is equal to 1 over 3. Then recall using indices, negative indices, that 1 over 3 is the same thing as 3 to the minus 1. So we can write 3 to the n is equal to 3 to the minus 1. And because the bases are the same, we can just simply say n is equal to negative 1. So that's how we start off, by looking at these very, very simple equations where it just takes one thing to be rewritten and we get our answer. Now let's look at another one that has a little more work. Here we have 9 to the x is equal to 27, and we need both of these to be in the same base. So we could try writing 27 as a power of 9, but if we do that, then what we have is 9 times 9, that is already 81, so it's way bigger than this, so we can't use 9. But what we can do is that we can write 9 as with a base of 3, and we can also write 27 with a base of 3. So we can write 9 as 3 times 3, or 3 square. So we have 3 square raised to the x is equal to 3 to the third, which is what 27 is. And here we can rewrite this as 3 to the 2x power times a power, raising a power to a power, is equal to 3 to the third. And once we've done that, then we can continue by solving our equation. Notice the bases are equal now, so we simply say 2x is equal to 3, and by dividing both sides by 2, we end up with x is equal to 3 over 2, and that is the solution we need for this question. Let's look at another one. Here we have 5 to the 3x is equal to 5 to the 7x minus 2. Notice that the bases are equal already, so we just go ahead and equate the powers. So we have 3x is equal to 7x minus 2. And then all we need to do here is to rearrange our equation by saying 2 is equal to 7x minus 3x. And therefore 2 is equal to 5. Is equal to not 5, to 4. 4x. Okay. And dividing both sides by 4, we end up with x is equal to 2 over 4, which is the same thing as x is equal to a half. And that is the solution that we get right here. In this one, same, we are raising a power. Now we need to rewrite this one as a power of 3, with a base of 3 rather. So we have 3 to the z is equal to 9 is the same thing as 3 squared raised to the z plus 5. And therefore we have 3 to the z is equal to 3 to the 2z plus 5. Now this is important here. This 2 multiply, this is a power raised to another power, so we multiply the powers 2 times that power. Now because this is an expression, we use a bracket. So now we can equate the powers. These are equal, same base. So we have z is equal to 2 bracket z plus 5, which tells us that z is equal to 2z plus 10. And solving this gives us a negative 10 is equal to 2z minus z. And therefore we get our z is equal to negative 10. So that is the solution for that one. Let's look at another one. Here we have one that has a little bit more work in it. Now notice first that we have 1 over 8 raised to the x minus 2. And remember that a to the m to the minus m rather is equal to 1 over a to the m. So we can rewrite this first as by saying 4 to the 5 minus 9x is equal to 8 to the negative x minus 2. All right. So here we go. Now we need to write both of these in the same base. So we can write them by saying 2 here, 2 squared. And that is raised to the 5 minus 9x. And here we have 2 to the third, which is 8, is raised to the negative x minus 2. Now, since they are both in the same base, now we can equate the powers by writing 2 bracket 5 minus 9x is equal to negative 3 from here into x minus 2. And so we have an equation that we need to solve. So 2 times 5 here gives us 10. 2 times a minus 9x gives us a minus 18x. And that is equal to negative 3x plus 6. And we simply need to rearrange this equation. So let's rearrange it. So we have a negative 18x here plus a 3x. And that is equal to 6 take away 10. So now we have a negative 15x. And that's equal to negative 4. And dividing both sides by negative 15. We end up with x is equal to 4 over 15. And that's our solution there. So it took a little bit more work, but the idea is the same. Write both in the same base, equate the powers, and solve. Here we have one that also requires some more work. Looking at it, we see 2 to the 2x plus 1 and plus 5 times 2 to the x minus 3 equals 0, which kind of looks quadratic. So we need to rewrite this equation. Now 2 to the 1, 2 to the 2x plus 1 is the same thing as 2 times 2 to the 2x plus 5 times 2 to the x, and here we have a minus 3 equals 0. Of course, realizing it looks quadratic, so we're going to make a substitution, and that substitution is let u equal 2 to the x, and if that's the case, then we can write here 2u squared plus 5u minus 3 equals 0. Now, the 2 to the x is replaced by u, and we have this 2 here, which becomes a power. So this equation can be factorized, or you could use the formula to solve it. And if we use factorization, then we end up with 2u squared plus 6u minus u minus 3, and that gives us 2u into u plus 3 minus 1 into u plus 3. So we end up with 2u minus 1 and u plus 3 equals 0, which tells us from this 2u minus 1, which tells us that u is equal to a half, and u plus 3 equals 0 tells us that u is equal to negative 3. Now remember, we made a substitution here. So u is 2 to the x, which this means that 2 to the x is equal to a half. And here, 2 to the x is equal to negative 3. Immediately, we can see the solution here by rewriting 2 to the x. 1 over 2 is the same thing as 2 to the minus 1. Therefore, we see that x is equal to negative 1. And so we have a solution. Looking at this one, 2 to the x is equal to negative 3. There is no number that we can use in the place of x to make this negative 3. So in this case, there is no solution. No solution here. But we do have one solution here. And so sometimes you may need to make adjustments to your equation, for example, here, to make a substitution and make it quadratic and find the values that you need. Always remember to check when you do an equation like this, when you need to make a substitution, because sometimes some of the values that come out are not actual solutions. They come out of the quadratic, but when you test them back in the original equation, then you realize that they're not quadratic. So then, they're not a part of the solution of the main equation that you were solving. All right. That's how we solve exponential equations. Of course, there are more that you need to practice. Remember to get some more practice. And of course, if you have not subscribed, please remember to do so. Thank you so much, and thanks for watching.